When we think about teams of AI agents, we usually picture this top-down system, right? Like one central brain pulling all the strings. But what if that whole way of thinking is, well, broken? We're going to look at a totally new way to see this, an analogy that really flips the script: the airport versus the classroom. Yeah, just let that sink in for a second. This question is really the key to unlocking a massive leap forward in what AI can do. We're talking about a fundamental shift, moving away from total micromanagement to a world of mass coordination. Okay, so here's the breakdown. On one side, you've got today's approach, the classroom. It seems neat, it's orderly, but it's got some major limitations. And on the other side, the new idea, the airport. It's dynamic, it's decentralized, and it is built to handle, well, a whole lot more. So let's dive in and figure out why the old classroom way is just not cutting it anymore. All right, so what exactly is the problem with this classroom model? Why is it holding AI back? It all boils down to one simple but huge concept: centralization. Just picture a real classroom for a second. With these multi-agent systems today, you basically have a single teacher. That's your central orchestrator. And this teacher has to manage a small group of student AI agents. It's giving out homework, it's checking every little piece of work, it's monitoring every single step. It's an incredibly hands-on, micromanaged system. And this, right here, is where everything starts to fall apart. See, a student agent can't do anything, can't move on to the next task without getting the teacher's okay first. So what happens if the teacher is busy with another student or has to correct a mistake? Well, everyone else is just stuck. They're waiting. The teacher becomes the single point of failure, the central bottleneck that grinds the whole class to a halt. And look, this isn't just some abstract idea. It's a real-world problem with a hard limit. You try to get more than, say, 5 or 6 of these agents working together in the classroom model, and the whole system just breaks down. It hits a brick wall. It absolutely cannot scale. So, all this inefficiency, it comes with a serious performance cost. Our poor teacher, the central orchestrator, has to burn through a massive amount of memory, just trying to remember what every single student is doing at all times. And that memory overhead, it's like a huge weight dragging the entire system down, making everything sluggish and slow for everybody. Okay, so the classroom is clearly broken. What's the fix? Well, let's leave the classroom behind and head to the airport, because this is where things get really interesting. This new solution is called a multi-agent network, or MAN for short. And you guessed it, it works just like a busy airport. Instead of students, think of each AI agent as a traveler. There's no teacher holding their hand and telling them where to go. Nope, they are autonomous, they're self-sufficient, and they know exactly how to get around the system all by themselves. And this table really spells out the difference. In the classroom, the teacher does it all, right? Registration, tasks, communication, everything. But in the airport model, the agents themselves take control. They sign themselves up, they grab their own assignments, and they find other agents to talk to directly. There's no central middleman slowing things down. So how does this actually work? Well, first, any new agent just shows up and registers itself on the network automatically. Then, and this part is really cool, they use something called gossip protocols to figure out what everyone else can do. It's kind of like looking at the giant departure board at an airport. Agents are constantly broadcasting their skills, their destinations, and other agents can just look up and see who they need to connect with. It lets them find the perfect partner for any job, get it done way faster, and even connect to other apps without a hitch. Okay, that all sounds fantastic in theory, but what does it actually mean in the real world? Well, the impact comes down to one word: scale. And the results are, honestly, staggering. Remember that tiny limit of 5 or 6 agents in the classroom? Well, the airport model just obliterates it. We're talking about being able to call on hundreds of agents at the exact same time, all working in parallel. It's like we've gone from a tiny study group to a massive, bustling international airport terminal. And the efficiency gains, they're just off the charts. By getting rid of that single bottleneck, the whole system runs with 15 to 20 times less lag and memory usage. That's not a small improvement. That is a revolutionary jump in performance. So why should you care about this? Well, for any large organization, this is a total game changer. Just try to imagine a big company with thousands of AI agents working across different departments, all doing these complex, interconnected jobs. The old classroom model, it would be an absolute disaster. But the airport model, this new system is built from the ground up to handle exactly that kind of chaos and complexity. And to put a fine point on it, as the folks behind this research said, this multi-agent network isn't just a nice to have. It's an absolutely critical piece of the puzzle. It's the technology that finally lets these AI agent systems grow up and handle the massive demands of the real world. All right, let's wrap this up. What's the big takeaway here? What's the one thing you should remember from all this? It really is this simple. We're moving away from a system that's defined by its central bottleneck and toward a new system that's all about autonomous scale. We are literally replacing that one single overworked teacher with a dynamic, self-organizing system where thousands of agents can work together efficiently. And that, of course, leaves us with a huge and fascinating question. Now that we've cracked the problem of scale, now that these AI agents can finally organize themselves, we've unlocked a whole new level of what's possible. So with these armies of autonomous agents ready to work together, you have to ask, what incredible problems, things we once thought were impossible, are they going to solve next?